When graphing quadratic equations, we will have the distinct U-shaped parabola, and we will have three different kinds of solutions when it comes to the quadratic. The first one would be two solutions. Two solutions. And this occurs when the parabola intersects the x-axis at exactly 2 points. The second type of solution would be one solution. One solution. And this occurs when the parabola only intersects the x-axis exactly once. And then finally, we would have no solution. This occurs because the parabola would never intersect the x-axis. To figure out which category our quadratic equation falls under, we will use this equation called the discriminant. And we will see that it comes from an equation that we're already familiar with, and it will tell us exactly why we have two solutions, one solution, or no real solutions. In short, the discriminant is used to find the number of complex roots in a quadratic, and it comes from the quadratic formula, in which we take the b squared minus 4ac term out and simply use it to find the number of complex roots. Just as we have three cases with our parabolas, we have three cases for a discriminant. When our discriminant is greater than 0, we have two real solutions. When our discriminant is equal to 0, we have one real solution and one imaginary solution. And when our discriminant is less than 0, we have two imaginary solutions. Going back to the graph of our parabolas, we can see that in a parabola in which we have two solutions, our discriminant would be greater than 0. In a parabola in which we have one solution, our discriminant would be equal to 0. And in a parabola in which we have no solution, our discriminant would be less than 0. We are given a quadratic equation and we want to find the number of solutions using our discriminant. Before we do anything, we want to remember that the coefficient of the x squared term is a, the middle term is b, and our constant term is c in this equation. So, using this information, we know that our b term is 1 squared minus 4 times 5, which is our a term, times 5, which is our c term. So we can simplify this as 4 times 5 is 20, 20 times 5 is 100, and we know 1 squared is 1. So we have 1 minus 100, and we know this is negative 99, which means we have no real solutions. We now have a different example, and we want to find the number of solutions to this quadratic equation. So, using our discriminant formula, we know that this is b, this is a, so negative 1, and then c. So, we have negative 4 quantity squared minus 4 times negative 1 times 1. Simplifying this would give us 16, so negative 4 times negative 1 would be plus 4 times 1. So we know this is 16 plus 4, in other words, 20. This means that we would have two real solutions. So we want to find the number of solutions to this equation using our discriminants. So before we use our discriminant, we're just going to factor this, and we can see that it is a perfect square, because if we were to expand this out, we would get x squared plus 6x plus 9. And so as we have a perfect square, we would only have one solution. So let's use our discriminant and see what happens in that case. So we have a coefficient of 1 for a, b is 6, and c is 9. So b squared, 6 squared, minus 4 times 1 times 9. And this is equal to 36 minus 36, or 0, which aligns with what we originally said. So in short, all perfect squares have a discriminant of 0, as they only have one solution.